So I believe that we're all only given one precious life. For those of us who are really lucky to be born, it's a life to be embraced, a life to be used for good, and a life that's worth prolonging in good health. Now, when we're all very young, we assume that our parents and our grandparents, all our loved ones, will be around forever. But then we learn that that's not true. I clearly remember my daughter Madeline, here she is. When she was 4 years old, I was putting her to bed, and she said, "Daddy, will you always be around to protect me?" Man, it even almost brings a tear to my eye right now. I think anyone who's been a parent knows how this feels. And I said to her, I had to be honest, I said, I'm sorry. One day, like everybody, I will grow old and I will die. And I watched her eyes well up, and she gave me a really big hug. But then I told her, I think what we all tell our children, which is just don't think about it. And so she did. But here's my big idea. I think we've all done this in our lives. We all try to forget about this truth. And ironically, I believe this is preventing us from realizing the lives we could actually live. So, you know, my grandmother, Vera, she's an amazing lady. She saved lives in World War II. She escaped persecution from Hungary and fled to Australia. She had a wonderful sense of humor, a love of life, and she spent a lot of time raising me. And she never wanted me to call her grandma, only Vera, because she hated the idea of growing old. But since then, I've watched her grow old. She's watched herself grow old too, and she used to apologize to me for it. A few months ago, I heard that she fell over in her apartment and she broke the top of her femur. She went straight to hospital. They operated on her. Her heart stopped in the operation, and I arrived in Sydney with my son, Ben, 5 years old, to say goodbye to her. She was there, just a shell of the woman she once was. She had a feeding tube coming out her nose. She barely knew who anybody was. And I thought, this thing we call aging, why aren't we up in arms about it? And this once vibrant woman reduced to this. It's incredible. And this is just my story, but this is being played out every day in everybody's family. It's certainly not an isolated case. In fact, I don't want to be a downer, but this or something like it is going to happen to all our loved ones, including all of us. And that's actually the best case scenario. So why aren't we doing more about it? Well, I think we all know that aging is important. For example, the World Health Organization recently put out a report, 32-page report, saying that aging is one of the biggest problems of our generation. Unless we do something to keep the elderly healthy and productive, the cost is going to crush national infrastructures, and our way of life, our economies, are going to fall. And this is what the governments are saying. But what you may not realize is a fraction of just 1% of medical research is devoted to understanding why we age, and even less is devoted to trying to do something about it. And this, to me, is a major puzzle. What I think is going on is that we just don't like to think about it. It's really quite weird. I noticed many of you chuckled when I was introduced. I think we're just ingrained to really not want to talk about it. We feel uncomfortable, embarrassed talking about extending lifespan and delaying aging. For many people, it's even sacrilegious. I once debated the bioethics advisor to President George W. Bush on national radio. His point to the audience and to me was, aging is natural. It's part of the way of life. In fact, it makes life worth living. What a load of bull. Alzheimer's, heart disease, cancer, these are natural, and we do everything we can to prevent and slow these diseases down. 99% of medical research is devoted to trying to slow down these diseases, which actually only a fraction of us actually get, whereas aging, if we're lucky, affects all of us. So you might ask, well, why don't we just continue what we're doing? Why don't we just study individual diseases? That's what we've always done. It seems pretty good. But what you may not know is that the rate of aging is actually decreasing. What I mean by that is that we've developed many medicines that actually can treat part of our body, say our hearts. We're very good at keeping our hearts healthy, but our brains still age, okay? So what we've ended up with are, and just to use my grandmother as an example, a nation of elderly whose hearts are working well, for example, but their brains are no longer functioning. And this is a major problem for our healthcare system. It's extremely, extremely expensive. What we need are medicines that will keep all of our body's parts working at the same time. And if we just fix one part of our body, the problem is that some other part will break down. We're just switching out diseases. And I don't think this is the right way to go about it. If you look at this graph, actually, this really brings it home. Now, we're always taught that our medicines are making us healthier for longer. That's not true. Look at this graph. The amount of time that we are spending in good health is actually decreasing in terms of percentage. No wonder healthcare costs are going up. What we need to do, of course, is to keep us healthier for longer. So I'm not talking about living for 500 years. I see that sometimes quoted in the press. But what I am talking about is an ability for us to live into our 90s and our 100s in a healthy way. And not like my grandmother, who suffers, and many of us will go through this unless we do something about the root cause of aging. And I would argue is the greatest problem of our time. Well, let me tell you about the work that I've been doing a little bit, about how I think we can get at the root cause of aging. So when I was in my 20s, I earned a PhD in Sydney, and I headed off to Boston to a place called MIT to understand why yeast cells, little budding yeast that we use to make bread and beer, why they grow old. Because I figured if we couldn't figure this out for a yeast cell, we had no hope of understanding why we grow old. Fortunately, I did. And even though there were critics of this approach, there were even Nobel Prize winners who told me, this is not the way to go about aging. Yeast cells don't get gray hair, they don't get heart disease, they don't get cancer. But I ignored them, fortunately. I was quite naive, luckily. And in the next few years, what we discovered as a group was that yeast cells do in fact grow old. And one of the reasons is that their genes start to switch on as they get older. So what I mean by that is that, so every cell has a set number of genes. We all know that. In every one of your cells, same number of genes. But they're not all switched on at the same time. They need to be kept on and off, and tell what type of cell is in the liver and what type of cell is in the brain. And what we found was that these yeast cells, as they got older, after about a week, all the genes started to come on, and they died. Now we could find genes that could actually slow that process down. We could find genes that could switch off those rogue genes and silence them. And this led to a discovery of a longevity gene called Sirtuin. And Sirtuin stands for Silent Information Regulator number 2. So in 1999, I started a new lab at Harvard Medical School. I was 29 and figured I could change the world. It was really exciting. We soon discovered that there are 7 of these longevity genes in our bodies. We call these the Sirtuins. So the Sirtuins have risen to scientific prominence. There's thousands of papers on these now. And what we've learned is that they seem to protect our body against diseases of aging. So for example, if you put extra copies of these genes into yeast and little nematode worms and flies and mice, they do a lot better. In fact, in most cases, they live longer in a healthy state. So what we need to do is to figure out ways to tweak these genes, to make them more active. And in that way, we might be able to delay all the diseases that we get as we get older, and possibly even reverse aging. So let me explain what the Sirtuins do in our body. And I've been very fortunate that the TEDx people have helped me make some videos here. There's a new idea about aging, and that is that as we get older, genes are switched on and off in the wrong way. So when we're young, there's a beautiful symphony playing, but as we get older, the instruments, the orchestra starts to play willy-nilly and screw things up. So if we zoom into the cell, you'll see a chromosome, and if we stretch out the chromosome, that's the DNA, all twirled up there in gray. The pink blobs are proteins called histones that the DNA is packaged in. Red means the gene is off. The problem during aging is that chemicals come in and stick to the histones and turn the genes on. So that's what the green lights mean. This gene that should be off in the brain of my grandmother is now coming on, and that's a terrible thing. And if this gene happened to be a gene that told the liver to be a liver cell, and now it's on in the brain, you can imagine the problem. And that's what we think may be a large part of what happens during aging. This leads to a really important possibility. We used to think that mutations, these irreversible changes to our DNA, are what cause aging. But in fact, if it's this what we call an epigenetic change, that's reversible. So let me show you how we can reverse it. So these sirtuins, they actually make proteins that I'm going to show a cartoon of. It's going to look like a Pac-Man. And what the sirtuin proteins do in our body is that they clip off these chemical groups, see? And now the gene that was on in the old person, green, goes off again. And that's what the sirtuins are doing in our bodies right now. They're stimulated naturally when we don't eat and when we exercise. And if we eat a large hamburger, we shut them down again. This is not good. So what we wanted to do was to find a way to turn the system on, find a molecule that could be taken in a little pill and turn on these sirtuin enzymes. And thereby we could clip off these chemical groups and keep these diseases of aging at bay and keep our whole body healthy. And we might even one day, in theory, reverse aspects of aging. So as I said, I was in Boston and things were looking really interesting. I started a company that was based on the discovery that there were molecules that could activate these enzymes. The one 10 years ago that we found, which got a lot of media attention, was from red wine. It's called resveratrol. And don't ask me to say that again, that's a hard word, resveratrol. And so resveratrol, as you probably heard, is in red wine. Now the problem with that is that you'd need to drink about 100 glasses of red wine a day. No, I don't recommend that. Don't do that. But what we clearly needed was a drug that would do this, something that's more effective, more potent than resveratrol. And this company, they raised a lot of money, and they set to find molecules that were even better than resveratrol. They found ones that were 100 times more potent than the red wine molecule. They put them into animals, and these animals, I'm talking about mice, they were much healthier. They didn't get heart disease. They were protected against Alzheimer's. They were protected against cancer. It was extremely exciting. They even started human trials, and the molecules appeared safe. And there were already hints, just little hints, that actually these molecules were working the same way as resveratrol was working to prevent these diseases of aging. And I'm hopeful that one day, hopefully not in the too distant future, there will be medicines that we can take, say a little pill. I've got an example of what it might look like. We might take one of these with breakfast, and that could ward off the diseases of aging until much later and keep us healthier and functioning. So I really look forward to a day when this happens, and when it does, I believe that we're going to look back at today like we do people from 100 years ago, when people would die from an infected splinter, which in those days, as you might recall, was perfectly natural. And I not only believe that we have a right to use this new technology to help ourselves and our loved ones, I believe we have a duty, a financial and an ethical one. And if you don't believe me, just ask any 4-year-old. Thank you very much.